Great. We continue going to Finland and jumping into the ocean and finding energy there. This is Aki Luukkainen of Wello. Welcome,
Thank
Wello.
you, Jan. There's been very interesting presentations yesterday and today about different kinds of applications and also about electric vehicles and so on. We work on the supply side, so there's huge amounts of resources available, meaning the ocean energy. And that resource has to be captured so that we can get CO-free energy for all of those EVs, all of the other applications or other devices there is in the world. And by doing so, obviously, we address a huge market. It's estimated to be 450 billion in the next 30-odd years. So this is the market we are addressing and at the same time saving the planet with CO2-free energy. So that's our goal. There has been quite many companies in the area of ocean energy that have burned huge amounts of capital. So the industry might not be that attractive for most of you investors. But as with any industry, any new innovation, there's the first phase, second phase, third phase, and so on. And quite rarely, the first companies really succeed. So the second ones or third ones that do things differently are the ones that will succeed. So in our case, what we have done, we have actually solved the challenge of offshore wave energy. The penguin there is just the name of the device, as with all of the ocean energy devices, there's some kind of a name of a sea animal. So we have solved that. We have a device that has been operational now for 3 seasons, so 3 years in Orkney, Scotland. It's a full-scale device, 1 megawatt device, and it has survived over 12-meter waves, so the waves from here up to the roof and more. And all the components inside that device are still original. So original components, no changing components or swapping components, which means that we really have a durable concept that can be installed in the ocean to harvest the energy and provide electricity to the grid. In terms of customer base, we already have a utility engagement. So a Scandinavian utility, Fortum, is planning to build a 10-megawatt deployment into Cornwall in the UK. In addition to that, an Irish utility, ESB, has selected us in their shortlist for a 5-megawatt deployment, which we will hopefully hear a bit more next year, which companies they will finally select into those deployments. But these two together, we basically have a sales pipeline of about 70 million. So quite attractive business in a short term already. What we are now looking for is equity funding to fund our preparation for these pilot activities. So quite reasonable number of money, 2 to 4 million, that we need for that. And just to mention how we differ from these first phase companies is that we have actually spent about 1/6 of the money to get to the same phase, having an operational full-scale device in Orkney surviving these conditions. What we are targeting, obviously, is a technology exit or IPO in short time frame. For any startup, it doesn't really make sense to build a huge sales, support, and operations network, because there's already available quite many of those from several companies. So we truly believe that we built the technology, and when it's time to build capabilities beyond these pilots, it's up for the bigger companies, or with IPO, we will obviously be able to do that as well. Now if we can get the video part, that will explain a bit the working concept of our system. It's a bit difficult to explain other ways. So this is Orkney, Scotland. There's about 5-meter waves last August. Our device is built like a ship. It's like a steel ship, moored or anchored to the seabed. And ships are built typically with stability in mind. What we have done is we have built the ship with instability in mind. So it does roll and pitch, but it does it in controlled way, so that the device actually makes this kind of smooth, very smooth movement, rotational movement or circular movement. And with that circular movement of the device, we capture kinetic energy inside the device with this red rotator, eccentric mass, which weighs about 100 tons. So it's rotating smoothly inside the device. So there's no moving parts touching seawater, and there's actually only one moving part in the concept, the rotator. That's connected with a shaft to a generator, and generator then obviously with some auxiliary electrical stuff to the grid. And as you can see here, the rotator follows nicely the angle that the hull actually creates and generates electricity. So very simple, straightforward concept as such. So that's the way how to make clean energy from these resources, like 60% in the US is possibility of making clean energy from waves. And then when we come back to the presentation, so as said, best innovations are really simple. In this case, there's one floating element that converts wave movement into kinetic movement inside the device connected to a generator. Another nice thing here is that we're actually repurposing existing components. We are utilizing a generator from wind power. We're actually using all the components inside the device as a proven industry components from other applications. So we don't waste any time on fine-tuning different components or creating own components. So motion is directly captured, or energy of the motion directly captured, without any joints, hydraulics, gears, or other stuff. It's a direct drive generator. All components, as said, industry standard components. So we get the kind of quick start from initial idea to the actual application and working application. Obviously, the next question is, but what about if someone copies your idea? Since it's a very unique idea, we have been able to patent the whole concept, not just, simple details of it, but the whole concept. And as said, components are from wind power. If we take a generator from wind power plant, we take rest of the components from wind power plant, and then we utilize existing supply chain, existing manufacturing capability, meaning shipyards building the ship. We are actually already in the same ballpark with the cost as wind power plants. So our target of getting to the same cost of electricity as offshore wind power plants is quite easy and straightforward if we use same components and scalable manufacturing as de facto. So this is the key to conquer the ocean energy. And to summarize why any of you would invest into us is, first of all, there's a huge market screaming for a solution. And once the solution is there, the market will open. There's also demand. There's utilities, and as you might have heard from a couple of days ago, Barack Obama's announcement of renewable energies in the US as well. So there's huge demand of renewable energies. And in general, obviously, we all need a solution for this. There's also maturity. So industrial companies have acquired already all the tidal technologies that were available within past 2 years. So all of those have been acquired with quite significant numbers as well. Wave energy follows tidal energy with 1 to 2 years behind. So I would like to see also some exits in this space, but there isn't really technologies other than ours. Because our solution, it uses wave movement. Instead of doing back and forth movement, it actually has a continuous movement. Less forces, more durability. We are repurposing existing technologies instead of developing new technologies. We are utilizing existing supply chain and manufacturing capabilities, which have all the quality, all the capacity that we need. And basically, using off-the-shelf components, we get a shortcut to the actual deployment of hundreds of these devices. So we have a solution with unique approach, and we have results available. The next question is, this is wave energy today, and which one of you want to be part of making this the mainstream energy for the future? Thank you very much.
Thank you, Aki.
Thank you. Yeah.
How much does one device cost?
The sales price, you might ask.
Yeah.
Well, the sales price still for the early devices is between 4 and 5 million.
4 and 5.
Yes.
Okay, and you have one in the field.
Yes.
Who paid for this?
That's the one that we had to pay for.
Okay.
The next one will be paid by the utilities.
Okay, cool. Do you have a question for Aki? Because he already has the microphone.
Yeah, I wanted to ask how you get the energy from the ship to the grid and what are the challenges in that transport?
Yes, so how we get the energy from the vessel to the grid is basically it's connected with an 11 kilovolt subsea cable, which is quite straightforward way of doing it. What distance? It's about 2 kilometers from the current site. What is the cost of such a 2-kilometer cable? In our first case, obviously, it was paid beforehand because we're testing it in a site, but it's roughly 10 kilometers is about 1 million deployed, so 2 kilometers is roughly in the range of 300 to 500,000. And obviously, you would put several devices to the one cable. If you build one farm, you have several devices connected with one big undersea cable to the land. Exactly. One or two, like in the wind part, 2 cables are typically used for redundancy. Yeah, and then I think Ruben, right?
Yes. Thanks. One question. What is your required financing? Sorry? Your financing requirements. Is it 5 million or is it more?
2 to 4 million is what we are currently forecasting for the next 3 years.
Okay, thanks.
Okay, thank you very much.
Thank you.